Mechanics problem. Wire bracket. A light inextensible thread 2L equal 2 meters long is held by its ends so that they are at the same height next to each other. A wire bracket in the form of an inverted letter U hangs on the thread. The mass of the bracket M equal 1 gram. The thread withstands a maximum tensile force F equal 5 newtons. F much larger than mg. The ends of the thread begin to move in opposite horizontal directions with the same speed v equal 1 meters per second. At some point the thread breaks. To what maximum height from its position at the moment of the thread break will the bracket fly? Ignore I resistance. So first of all, let's draw a picture. We have thread in some position after these ends move on distance vt, and now we have height, the difference between the horizontal and the position of this bracket. So on this picture we see the speed of both ends, it's v in opposite directions. We have mg applied to bracket, and we have two tensions T. So this is all what we have. Now we can find what is height h as a function of time. This is the formula for height as a function of time. We did it from this triangle. Next step, we have to find what is the vertical speed of this bracket and what is vertical acceleration of this bracket. After that we can find what is tension finally. So let's do this. First we have Vy equal first derivative from h over dt, which we can count, and this is the expression. We made it positive because we need to find what is the absolute acceleration to positive up direction. Next step is to find what is acceleration. That will be derivative from velocity. This is the expression, how to count it, and finally we got this answer for acceleration. Next step is to write a Newton equation for this motion of this bracket. This is the formula. We have MAY equal force from this thread minus force of gravity mg. And from here we can find what is force Fy. This will be this expression. Here we use expression for Ay, which we already counted before, and this is our expression for Fy. But from other hand, we can make this Fy using tensions, and that will be equation for that. So we have Fy equal 2 tensions multiplied by cosine of this angle between vertical and direction for thread, which is h over L, and this is the formula. And now we can equalize these two parts and use this knowledge that height h equal this expression, and we will get this expression. Now we can count what is tension in this expression. That will be this function. Here we use this expression that this square root equal h. Now look at this equation. If we try to solve it from point of H, that will be a polynomial equation power 4, which is not good. But we can assume that because this tension much larger than mg, this height h will be much less than L after all. And in that case, look at this expression. Here we have, if we check what is L square over h square, that will be a very big number. And also we have speed is 1 meters per second, and h much less than 1 meter. So totally that will be much greater than g, at least probably 500 or 1000. And in that case we can just neglect g and rewrite this equation in form of this one. And now we can count what is height h for tension T. That will be this one, root 1 over 4 from this expression, mv square L power 3 divided by 2 tensions T. Now we can use numbers to estimate what is our approximate h. So we have mass is 1 gram, which is 1 over 1000 kilogram. V square, that's 1 square. L cube, that's 1 cube. And 2 tensions, that's 2 multiplied by 5. So totally we have 10 power negative 4 here. And root 4, that will be 0.1 meters. And now let's check if we did a correct assumption about this estimation. Here we have v square, that's 1, L square, that's 1, and the h cube, that will be 1 over 1000, which give us 1000 for this member and 10 for this member. And of course we can neglect this g, and that will be almost a correct answer, very precise answer. Now, next step, we can find what is the speed in this point of break. Look at this formula for speed. Here we have v square multiplied by t, but v multiplied by t, that's length of this part. And for small h, that will be almost L. So we can, instead of Vt, put here L, and we have VL here, and we have h here, which already counted. So finally we have speed equal this expression. Approximately it's v multiplied by L divided by h. When we put numbers, we have 1 multiplied by 1 divided by 0.1, which is 10 meters per second. And for 10 meters per second we can find what is total height which this bracket will travel. This we can find from hy equal vy squared over 2g. If we put numbers, we have 10 square over 2 multiplied by 10, that's 5 meters. This is our answer.